Alright, so today we are supposed to talk about function pointers, right? So yesterday we've seen what structures are. We've seen why we need structures. We've also seen how to define them, how to initialize them, and also how to use them. So today we are going to talk about a concept in C which is also called the function pointers. So we all know what a function is. We also know what a pointer is. A pointer is simply a variable that holds the address of another variable, isn't it? But in the case of function pointers here, the pointer is not pointing to a variable. Instead, it's pointing to a function. Okay, that's also what a function pointer is. A function pointer is a pointer that is pointing to a function. Instead of a variable, that is in normal pointer case, the pointer points to a variable, right? But in this case, it is not pointing to a variable, it's pointing to a function. So, whatever you have stored on your machine, it has its own address, right? We've seen that how to find the address of a variable. Alright, so let me create a test file to explain this. So, so if I do something like hash include, this is what we always do, stdio.h, and we do something like int min void. So this is a function. We all know this min here is a function, and we've seen that, right, when we're talking about functions. So this function here itself, it's stored in an address. It is stored in a memory, and this memory that this function is stored has its own address. Anything that is stored in the memory, we know that it has its own address. So if you have, let's say this is the memory now. Let's say this is the memory, right? And you have your function, your main function. So let's say this is where it is stored in the memory, this portion in the memory. And this portion here is going to contain the lines of code. We know that it's going to be converted to machine code first. So it's going to store this in the in the memory allocated to for that function. And here, let's say it has the base address of 100. So it means that this 100 is the address for this whole block, isn't it? The base address of a memory block is the address of the block entirely, isn't it? So this main function now, what is the address of this main function? The address is 100. So I just want to show you that the main function also, or any function, is also stored in the memory, and you can get its address. Do you get it? So here, if I should now say printf, I want to print the address. I want to print the location where this main function is stored now. So I can use %p here, right? So here I need to pass the function name. What is the function name? It is called min, right? So if I do like this, it's going to print the address. Let's see. So gcc test.c-ot. Alright, so let's run it. So did you see that? I got the address. So this is where min is stored in your memory. Do you get it? So also, if I do something like this now, we know that whenever we are trying to get the address of a variable, we use the ampersand, isn't it, before that variable? Why is it that in the case of this function, I did not use the ampersand and I got the answer printed exactly? Let me use the ampersand in this case. Do you think I will get the same output? In the case of function, no matter how you do it, it's going to get the correct output for you. So in the case of function, it doesn't matter if you add the ampersand or if you remove it, because the function here what we are passing as argument to the printf is not a variable. In the case of variable, it will not work like this. You know that it will not work without the ampersand. You need to pass the ampersand. But in the case of function, anyhow you do it, it's going to work. So let's compile. So did you see that it worked? So if you like, consider the ampersand. If you like, don't consider the ampersand. Okay, so I just want to show you that functions also are stored in the memory, and they also have their own address. So now here, let's say I have a function that will find the sum of two numbers, right? It takes in argument int a, int b. So So these are the arguments that the function takes. So how is this supposed, what is this function supposed to hold? Is simply return what? A plus B, isn't it? That's also what the function should do. So let me define the prototype here. So int, right, sum. I can define the prototype here, not necessarily inside my main.h. Yeah, I can do it here. So I would now say what should be the, I can just pass in just the data type int. It will still work even without passing the variable a and b. The what matters is just the data type. So here I have this function, right? I have this function that will what? That will calculate the sum of two numbers, right? So here in this case, how do we initialize or how do we declare a function pointer? I want to declare a function pointer that will point to this function directly. So anytime I want to point to this function, I will just call the pointer and then it will point me directly to this function, just like the way we normally do in case of variables, right? When we declare the pointer with the reference, isn't it, to get access to what that pointer is pointing to. So how do we declare a pointer to a function? I want to declare a pointer to this function here. What is the return type of this function? It is an int, right? So the first thing I need to pass to my function pointer is int. That is the return type of the function I'm pointing to. Do you get it? So the next thing we need to pass to the function pointer is, what is the name of my function pointer? What name do I want to give it? So I want to give my function pointer, since it is a pointer, I need to add this. And what is the name? I'm calling it add, for instance, since this is going to sum two numbers, right? So after this, what next? So the next thing we need to do is, what is the data type of the function you are pointing to? What is the data type of the parameters? Int, right? The data types are integer, isn't it? So I'll just pass in int, comma, int here. So this is simple declaration of a function pointer. You are pointing to sum, isn't it? So your function pointer should be declared in such a manner. The return type should be the same as that of the function. Then here you need to pass the function name, isn't it? Sorry, the function pointer name, the name you want to give your function pointer. And the next thing is to what is the data type of the functions you are pointing to. If this function is pointing is taking what? Characters, then this has to be what? Characters. Do you get it? So now you've declared a function pointer. So assuming now I have something like this. Let's say I have another function, int sub, for subtraction. So this is also int, right? A, int b here, right? So this is supposed to take what? This is supposed to return what? Return a minus b, isn't it? And let's say I have another one for multiplication. So let's say int a, right? Int b, right? So this is supposed to return what? This is supposed to return a times b, isn't it? So I have these three functions here. Let me add their prototypes here. Sorry. So int, so int sub in this case, right? So it's taking also int and also another int, right? Then another one is for multiplication, which is also int, comma, int. So if you notice something here, our function pointer here is pointing to which one? It's pointing to sum, right? But when you look at the remaining function, it is the same thing. The return type is also int, and also the parameters the function takes are also int. So it means that in this case, the function pointer here will be confused. The function pointer will not know which of this function you are pointing to, because all of these three functions here what have met the requirement for this, for this function pointer. So how do we do this? This is where you initialize. Do you get it? This is where you initialize. So in this case here, I can simply initialize this function pointer. So let's say I want the function pointer to point to sum. Do you get it? To point to sum. So I can simply say equals to sum here. So this is what equals to sum. So now let's try printing this. what if I say, before that, let me say result, or let me declare the variable first. I need to declare result, int result here. I want to store whatever the function pointer is returning. Do you get it? So here I can now say result is equals to what? What is the name of my function pointer? The name is add, isn't it? So I will now call it add, and then what? It's taking two parameters, integers, right? So I will now pass in what? Let's say 5, 2 here. Do you get it? So here I can now say printf here. So what should I print? I'm printing the result %d, right? So here I will pass in result. So let's see what will happen in this case. So let's compile. All right, so did you see that I got 7 printed because I called the sum function, isn't it? Add, because I initialized the pointer add to what? To sum. What if I change this to subtraction, to sub instead of sum? It's going to -2 from 5. Do you get it? Because I already have the function here, sub. So now I'm initializing my function pointer to point toward this sub function here. So let's try again. Let's see. So did you see that I got 5 minus 2, which is 3? Right? So if I change this to mul now instead of sub, I'm still initializing the function pointer. If I change this to mul, what will happen? It will call this function here. Yeah, so and it will multiply them. So what will happen? What am I expected to get here? I'm expected to get 5 times 2, which is 10. Did you see that? So this is what? Simply how to initialize a function pointer. Okay, so now we've seen the different ways to we've seen how to declare the function pointer. We've also seen how to initialize the function pointer, right? So one of the things that we use function pointers for is what is called a callback function. Okay, it is what is called a callback function. What is a callback function? It's simply a function taking another function as its parameters. Do you get it? The function is going to take another function as parameter. Let me comment out this part now. This entire part in the main. Yeah. So now I don't have this. So let me try creating another pointer, another function. And this function is going to hold a callback function. Like I said, a callback function is simply a function that holds another function as its parameter. So I want to create another function here, which is going to be a callback function. So what I need to do here is I want that function to point to any of this, right? So the return type of this function is what? Is int, right? So and in this case I'm calling my function let's say output here, right? This is how a normal declaration. This is just a simple declaration of a function. So in this bracket for this function, I will now pass in what? A function pointer. Do you get it? I'm pointing to a function. It means that this function output is taking a function now as its parameter. So I'm pointing to one of these, either int, sub, or mul, anyone, right? I want my function pointer to point to any of this, depending on what I want the function to do. Am I interested in summing? Am I interested in subtraction or multiplication? Right? So here I will pass in, I will declare my function pointer here. So int, so what should be the name of my function pointer? Let me call it pt, for instance. Then here it will take in what? The parameters, which is what? Int, isn't it? And what? And another int. So this function here is taking what? A function as its parameter, because this is pointing to a function, isn't it? This is pointing to which function? One of these 3 functions, right? So and this function output is taking it as what? As its parameter. So this is a callback function now. Do you get it? So all I need to do now here is I can now say pt here. I need to initialize my pt now, right? So my pt is supposed to take what? 2 arguments, isn't it? So I will now say pt, and then let's say I pass in 4 and 5, for instance. So I'm passing 4 and 5 as the argument to output. So now I have this now, this output here, and this output is pointing to all of this tree, or let me say any of this tree. So how can I get this function here to what? to perform whatever function I want to perform. Is it summation, is it subtraction, is it multiplication? So I have declared it now, and I have defined the function pt, right? So I can come to my header file, inside my main.c. All I need to do here is I will now say output. Now I'm calling this function here, right? And don't forget, this function is pointing to summation, subtraction, or multiplication, isn't it? So inside this output, what is output taking? Output is taking a function as its parameter, isn't it? So since I called output here, I need to pass what? A function as its parameter. So let's say I want to sum this 4 and 5. So I will just pass in what? Sum here. I will just call the function here, because output is taking a function as parameter. Do you get it? So let me just create another variable to store it. So instead here I will now say I is equals to output and this. So I can now use printf. So I can now say printf is printing an integer, right? So percentage d, a new line, then I here. So I have this, right? So let's see what will happen. So gcc what output, did I not declare it? Okay, yeah, I did not declare the function prototype, so I have to put it here. So I declared the function prototype now. Let's test the program now. Okay, so compile again, gcc, yeah. So let's run it. So did you see that? Did you see that we got 9, isn't it? That is 5 plus 4, I think, right? That's what we added. Okay, so now what if I add, instead of passing sum as output here, if I should add sub here, what is this going to do? It's going to print 4 minus 5, which is what? A minus 1, right? So let's run this. Oops, not this. Did you see that we got a minus 1? So this is the use of a callback function. So if I should do something like, let's say instead of sub, let me just say mul here. So did you see that I got 20 now? So callback functions are important when you are trying to deal with a lot of cases. Let's say you have a program to deal with different cases, just like the switch case statement. Okay, that's where callback functions are used. Just like in this case now, we have 3 different cases to consider. So as you can see, callback function is the easiest way to solve this problem. We just create the callback function, and for any function we want to use, we just pass this as the parameter, isn't it? Here, as you can see, I have what? I have 3 functions, right? The sub, the sum, and the mul. So I can create an array to store them. Since all of these functions here are of the same type, I can create an array to store them. So how do I create an array of a function pointer? I can simply pass in the data type int, and here I will pass in what is the function pointer name. Let me call it pt, and then I will pass the size. What is the size? I'm having 3 functions to store inside, right? So I just pass in 3 as the size. Do you get it? I'll just pass in 3 as the size. That's all. So here I will just pass in the data type int. This is what? Creating an array of a function pointer. So here I can just initialize. So what do I want to store? I want to store sum, sub, and mul functions inside this pt, right? So I can just say sub, sum, and mul here. That's all. So I've created an array to store this. We are not going to go deep into this, but I believe when we begin example, we're going to see how to use arrays to store these function pointers. But this is how to declare a function pointer in an array format. Alright, so let's see examples on function pointers.